Welcome to day 2 of long distance learning with LCA Physics. Today we will continue with what we talked about yesterday, and so the topic for today is going to be the anatomy of a wave. So in this setting today, we're going to talk about all the pieces and parts and vocabulary that labels the diagrams for the different kinds of waves. Okay? So, the very first thing I want to do is let's draw this picture on our papers. I usually draw a line that looks like this. It's like a big sideways T. And this is going to be the start. And I'm going to draw a wave that looks like this. And I'm going to cut it off right there. Okay? Now, if you've seen this wave before in a math class, it would be called a sine wave. In physics, this is called a transverse wave. Now, there are several different types of waves that have this shape. For example, we often think of water waves as having this shape. We also know that, or we should know that light, all forms of light travel as transverse waves. And so the next thing that I need for you to do is to label this. Now, on the physicsclassroom.com, which we're also using as part of our long distance learning, you may have already seen some of these terms, but let's just review these and make sure everybody's on the same page. The bottommost part of that wave is called a trough. And you think about a trough as being something that maybe an animal would eat out of, and you can see that it looks like a little bowl-like area right there. The top of the wave is like the top of a mountain. It's called the crest. The distance from this midline to the highest point or to the lowest point, like that, is called the amplitude. And then, this is a special definition that I want you to write down, the term wavelength. The term wavelength, which actually has a symbol, which is the upside down Y, which is a Greek symbol lambda, represents wavelength. And the definition that I want you to write down, and I'm going to repeat it twice, the place on a wave to where it reoccurs again. We'll say that again. The place on a wave to where it reoccurs again. So, for example, if we start at the top of this crest, that wave will continue until it gets to the top of the next crest. So we would draw a line across here like this, and we would put it upside down Y to represent a wavelength. But it's important for you to understand we could start a wavelength at any place, and it would extend to where that place reoccurs. So if I was starting right here, I would go through the wave to right here, and that also would be considered a wavelength. Now, if I drew that wave properly, that length and that length should have been the same. So on a transverse wave, we've got 4 basic parts. We've got the trough, the crest, the amplitude, and the wavelength. Now, in the second form of wave, which I'm going to draw right here, again, I'm going to draw the line like this, and this one is called a longitudinal wave. And it looks an awfully much like a slinky. See if you could draw that on your paper or in your notebook. Okay? So that's supposed to represent a longitudinal wave. Another name for a longitudinal wave would be a compression wave. Okay, compression wave. And you can see right here where the slinky appears to be compressed or pushed together. And so there are names for the parts on this wave that are some of them are different from over there. Right here, where the wave is smushed together, is called a compression. No secret, which is why it's called a compression wave. The part that I always thought was difficult to remember is the part right here where it is not compressed, where it's stretched out. And that place is called a rarefaction. Rarefaction. Now that's a word that very few people have in their vocabulary before today, so make sure that you write that down and know that that's the space in between the compressions. Now, like over there, any point on the wave to where it reoccurs is considered to be a wavelength. So if I start at the very beginning of that rarefaction, or you could say at the very end of the compression, and I come over here to where that point reoccurs, then that's the wavelength. And so in this diagram over here, if we started at the beginning, I would say that there is 1, 2, 2.5 wavelengths. Okay? One full one, a second full one, and then half of the third one. So that's 2.5. Over here, if I start at the beginning over here, I've got 1, 2, 3, 4, 5. So I have 5 wavelengths in this particular diagram. I hope everything there is easy to understand, and we'll look forward to seeing you in video number 3. Thanks for watching.